I should have recorded at the beginning. So sorry. All right, if you're watching this recording, you'll notice that I'm already 36 slides in. Sorry about that. Basically, talking about implementation and getting ready for software. Pretty much can follow my slides prior to this point. You won't be too far off. One of the things I want to stress with software production is process becomes super important, and it's the only way to really implement software quality and try to get that improvement to the quality that's coming out. Part of that process is the aspect of peer reviews and unit tests, where when you write your software, you have others, your colleagues, reviewing your software, seeing if it requires help. And of course, running that software through a test that looks at the interface and confirms the output is another aspect to this. So controlling those is very important. So it is best industry practice. You'll find most um, key good program managers dealing with the software realm will have these aspects of peer review and unit tests very well integrated within the whole software implementation process. So basically with peer reviews, now you have things like software inspections versus software walkthrough. Now, inspections are just kind of looking at your software, making sure it conforms with whatever standards that you're expecting, and making sure you're following the rules of construction. Now, a walkthrough is actually looking at actually how the software is constructed from what you want it to do. Is it meeting the requirements? Are you doing the right job? Is it correct and is it complete? So it's those type of things that you look at for that. Now, unit test is where you'll actually take it and throw it through what's called a white box. You just try to make sure you understand how it's being implemented, how it's being used, and making sure the statements you put in your code are being used correctly when it gets implemented and it's actually running. So unit test is you run it through its paces, so to speak. By the way, before I get into heuristics, are anyone out there actually done some software or are software engineers that maybe can add to what I've said? Are there other aspects that you can bring to software that you find very helpful? If you're not software, that's fine. But see, it's when you guys don't talk to me, I just don't know if you're awake or you left to eat dinner. So while I'm talking. So, all right, everybody's good, I guess. So that's good. All right. So what I want to do real quick is go through some heuristics here, and then we'll try to get you guys ready for your exercise. So basically, what I wanted to do is think about the fact that if you find a software problem when you're actually after you deliver it, you'll have to go back and actually fix the problem from design on. So it's like 100 times more expensive than if you found it back at the very beginning when you actually developed the design. And every design dollar you spend on development, $2 is spent on maintenance. So that's a good heuristic when it comes to how much this works. Now, there is some aspects to source lines of code that can be questioned. Some people like looking at function points, but if you do it correctly, you can actually see the cost of your software development and the type of maintenance costs you need by looking at the source lines of code as you go forward. And of course, because this is a very creative pursuit in terms of building software, you really, it behooves you to go find good people and hire them as you go forward. And also adding more people to a project. Now, this is true for software or not software. If you have a project and you feel you can throw more people at it and it'll be faster, there's a kind of a truth to that, but within a limit. You put too much, you'll compress it by 5%, but no more. If anything, you may actually drag out the project even further if you throw too many people in it, because now all these people have to communicate with each other, and they're not getting the work done. So you need to be very careful about adding more people to a project. Also, about 15% of the development effort is devoted to programming. Now, what is the other 85% working on? That's the actual difficult part of actually conceiving and designing the software. Software system products usually cost 3 times as much as the slot of individual programs. So system of systems can cost 9 times. So the more software you build, the more expensive per source line of code. Walkthroughs will catch a lot of the errors, especially with stylistic issues and performance and major problems. Well worth going through the walkthrough route if you could. The other one is the 80-20% rule. 80% of the engineering is consumed by 20% of the requirements. 80% of the contribution comes from 20% of the people. 80% of the errors are usually 20% of the components. 80-20. It's almost like a rule of nature as you go through that. So, is there any other heuristics that you guys, if you've done some software programming? By the way, raise your hand if you've actually done any software program. And if you don't, raise your hand. I know you guys are mainly all hardware. So Will has. Good. And should we? Well, if you guys want to come in and answer or add to this in terms of software, is there anything I'm kind of off on or something I should talk more about?
Well, I guess it really depends if you count MATLAB as software, which if you talk to software people is a no. But yeah, just going on what you said a little earlier about how it takes a very long time to explore all the branches and possible code paths you can go down. We have a model that we've been testing for months, and occasionally we still get an error or different things just because certain parameters get set different ways. And as you go down all the different possible code paths, turns out like millions of different iterations there are. So
do you actually have a time frame of when you think you would, or are you trying to get a certain percentage? Like if you could get 80% tested, we'll go forward or something like that. Or are you trying to do 100%?
no, that's exactly it. We're delivering the model at like 90% completion.
Right.
And that's supposed to be at the end of this month. So
Wow, yeah. And I guess computers being a little faster, you can kind of set them up to do the paths and just let it run 24/7. So
yep, pretty
yeah,
much.
yeah, great, great. Will, thank you so much. Anybody else have anything you want to add? All right. Now, one of the reasons I do this is try to get you kind of more understanding of what's involved in software system engineering, because you really have to bring in those software domain experts to help you if you don't have that. And you want to listen to them, because if they've been through some of the things Will and others have been through in terms of developing software, it is a difficult process. So kind of try to keep an open mind as you work in this. Now, what I want to do is talk about what a cause-effect diagram is. And there's different ways to, and I want to talk about these steps, because these are the steps I want you to use in your teams. Now, do you guys have your teams? I notice there's only How many of you here? 1, 2, 3, 9. Okay, so you guys, most of you might have your teams here. Let me know if you're missing some of your teammates, or if you could go ahead, since you're muted anyway, text them and see if they can come on board, because I like the teams to work on this if they can. That'll be good. All right. So basically, step one, you agree on your effect statement. We'll talk about what that'll be for the exercise. But one of the things, once you get together as your team, you have to start talking about your main categories. Now, we have 4M, 4Ps, 4Ss, whatever. It turns out that you can actually combine these. You can have methods, machines, people, and policies, 2Ms and 2Ps or whatever. So I want you to think about that end result, be it negative or positive, and think about what are the things that would, the main categories that would actually be involved in causing that effect as you go on. Now, then you identify causes within those main categories. So like, for instance, if you're getting poor gas mileage, is it because you drive too fast or using the wrong gears? That's methods, or your materials could be wrong. So it's that type of thing where you actually look at each individual cause. So that's step 3. And then step 4, you actually start asking the whys of those causes. Like, why are you using the wrong octane gas? And is it because you're ignorant, or is it because you don't even have the owner's manual? So the whole idea here is if you keep asking whys enough, you can get to a root cause, and you can actually say, hey, I might be able to solve this by making sure the owner's manual is available at all times, or writing octane gas only on the tank lid. So there's ways where you can actually look at this and go, hey, we can actually come up with some solutions. So 5 whys and analyze is really a great way to figure out those details. Here's some more examples talking about computer downtime from a software user hardware environment. Notice these categories don't even rhyme with M or P, but it is something, again, it's up to you in terms of what's the best way to look at it. These are 2 E's and 2 P's, the environment, equipment, procedure, and personnel, looking at an error-free document. Now, the reasons I give you examples like this is you'll be able to go in and look at these and maybe give you some ideas for your cause and effect diagram that you're going to do. Now, what we're going to do is go ahead and listen to this story as a team. I have to make sure you can hear. Oh, shoot, I must have. All right, let me pull this up real quick. Don't believe this will get in your way. Oh, must have done. All right. And by the way, Alden, if somebody has if you're Alden's teammate, maybe you can help him since you're on board and he's not. Maybe just reach out to him and see if you can get him in. All right, let me pull up this over here. Sorry about this. I had this up, but somehow I lost my thing. So I'm not immune to technical difficulties as well. Okay. Blackboard open. Courses. All right, let me change something up here. Let me hide that. Share screen 1. All right. If you go in here, you'll see my lecture notes, and down here, I actually have some Apollo 11, where we're going to actually listen to this. Oh, shoot. Let me kill this again. Sorry. Start it up again. This time include computer sound. All right. So if you have any trouble or can't hear this, just go ahead and maybe go into your Blackboard. You'll be able to pull this up. But let's listen to this. It's about 7 minutes long, and we'll talk about it afterwards in terms of for the exercise.
40 years ago today, 3 astronauts blasted off from the Kennedy Space Center in Florida. They were beginning the historic Apollo 11 mission, the first manned voyage ever to reach the surface of the moon.
It's one small step for man, one giant leap for mankind.
Hundreds of millions of people watched on television as Neil Armstrong took that first step. But the pictures that people saw were dark and fuzzy. The astronauts actually sent back better images, higher quality footage that was recorded by engineers on Earth. But 3 years ago, NPR reported that those original tapes were missing. Our report helped to trigger an exhaustive search by NASA. And NPR's Nell Greenfield-Boyce recently got an exclusive sneak peek at the 1969 moonwalk like you have never seen it before.
Stan LeBar is almost 84 years old. Decades ago, he led a team that designed and built a TV camera that is currently on the moon, right where the Apollo 11 astronauts left it. LeBar says his camera actually captured better images of their moonwalk than people saw on TV.
It was better. We knew it was better.
But the lunar camera recorded in an odd format that was incompatible with the normal TV format. So when the footage was received on Earth, it had to be converted for broadcast. That conversion degraded the image. However, engineers on the ground did record the unconverted raw footage onto tapes. LeBar and some colleagues recently decided to go back and look at those tapes.
The whole thing started with the idea that this is the one piece of television footage that's going to be played for the next 50 or 100 or 300 years. Those that follow us deserve better than what we had.
But the tapes were missing. For the last 3 years, a monumental search has been underway.
We had hundreds and hundreds of leads coming to us during this period. Every one of them was investigated.
LeBar and other searchers spent hours and hours in a vast government storage facility known as the Washington National Records Center, something that sounds like the giant warehouse at the end of the movie Raiders of the Lost Ark.
Stacked with racks of documents, tapes, all kinds of things from NASA and other agencies.
Dick Nafsker is a TV specialist at NASA's Goddard Space Flight Center in Maryland. He became the unofficial leader of the search team. He says they also went to remote storage facilities, to private homes. They pored over logbooks and memos and all kinds of 40-year-old handwritten records.
We went through old file cabinets that would have little record cards and give you an idea from a shipment went in with the name Apollo on it, and did it have Apollo or tape, or did it have anything on there that could be a tape?
They returned again and again to that vast government warehouse, but then they discovered something disturbing. Over the years, NASA had removed massive numbers of magnetic tapes from the shelves. Between 1981 to 1983, NASA permanently withdrew over 40,000 boxes. Why? LeBar says new satellites had gone up. The satellites were producing a lot of data that needed to be recorded.
These satellites were suddenly using tapes 7 days a week, 24 hours a day.
And the agency was experiencing a critical shortage of magnetic tapes. So NASA started erasing old ones and reusing them. That's probably what happened to the original footage from the moon that the astronauts took with LeBar's camera.
So I don't believe that the tapes exist today at all.
I mean, are you sad about that?
Yeah. Well, it was a hard thing to accept, but there was just an overwhelming amount of evidence that led us to believe that they just don't exist anymore. and you have to accept reality.
You may have to accept reality, but that doesn't mean you have to give into it. Nafzger says, look, they started this search with one goal.
Our goal was to provide to the world the best possible video of a historic event we could for the future.
Since the raw footage was gone, the team decided to try to find the best of what was preserved in the converted broadcast format. Nafzger says they looked through tapes in Australia, tapes in the CBS News archive, stuff no one had looked at in decades.
We found immediately that just because it was broadcast didn't mean it was similar quality. The quality of broadcast TV in existence of 1969 broadcast TV was varied extremely between sources.
Using all of these sources, they pieced together the best possible version of the moonwalk. And then, to make it even better, they turned to the magic of Hollywood.
We had been in contact at that point with a company called Lowry Digital in California.
They contacted me at Lowry Digital here in Burbank with the objective of can this material be restored?
John Lowry has a lot of experience doing high-quality digital restorations of old films.
Such as Old Bambi, Cinderella, Lady and the Tramp, 20 James movies.
And the Star Wars films, just to name a few. Early in his career, Lowry had actually worked on footage from later Apollo missions. So he was excited to have the chance to work on the first moonwalk. Over 100 computers processed the images, carefully removing things like random noise and camera shake, without destroying the image's historical legitimacy.
We've got to be very, very mindful of history. If you want to go to the extreme, you could take these images and completely recreate them. You could create a three-dimensional model of the lunar lander, and you could make it look beautiful. But I don't think that's the point. I think the point is that Apollo 11 was a very, very special historical event.
Last week at NASA's Goddard Space Flight Center, Dick Nafzger sat down at a computer loaded with the restored video, which he just received from California the day before. He called up a side-by-side comparison of the old and new. On the left side of his monitor was the dark, murky footage of Neil Armstrong coming down the ladder of his LEM spacecraft, about to make his first step.
As you can see on the left, there's nothing but a dark image and possibly a foot. If I told you it was a foot, you'd probably say, okay, it must be a foot.
On the right hand of his screen was the new version.
You can see the structure of the LEM. You can see his full outline of his body, his helmet, a reflection in his helmet. It's still not pristine, it's not clean in detail, but it's now an astronaut, and it's something no one saw before. This is the first step on the moon.
The restoration won't be complete until the fall, but NASA is releasing some short clips today to mark the 40th anniversary of Apollo 11 blasting off of Earth towards its moment in history.
Okay, what I want you guys to do is through this and everything I've told you, what I want you to do is, oh yeah, it's over here, is go into your teams and pull up your files over here, and you should be able to pull up the CE diagram template. And you should be able to work together on figuring out what the category should be. Now, the effect, you guys, I want you to type in the effect to be, how could we, it would be negative, right? How to prevent lost tapes. What could you have done to prevent the losing of those tapes? So that's kind of a negative kind of question. If you think of a better way of stating it, that's fine. But we'd love to see what the categories you pick, the various causes, and the whys. I'm going to give you about 20 minutes to work on this. And when you're done, I'll go ahead and pull it up, and just be sure to choose a speaker. Can you guys hear me? It looks like I froze. Hello? Did I freeze? Gotta love my... Huh?
I think you are frozen though.
Here, let me see if I turned it off and back on. Nope, I'm frozen. Okay, we'll just leave it off. But go ahead and do that. Can you see my screen? That's a good point. Can you still see my screen?
Yes, we can.
All right. So go ahead and get into your teams. Start up your getting together with your class teammates and start working on class 6, the CE diagram. By the way, I also have a PDF there if you want to look at what the diagrams and maybe talk about some of the actual things that you might use for the categories. All right. All right. So get to work. Let's try to get back here a little before 6 o'clock, like about 6. No, it's 5:30. Yeah, about 5:55. Let's try to get back here at 5:55. All right. And from there we'll figure out where you guys are. Okay. All right. So and I'll pop in every now and then as you guys go. Okay.
Professor Martin,
Yes, Marcus.
could you just repeat the effect that we were going for?
Yes.
I didn't
Actually, if you're team 1, you're all set. But
I'm team 4.
yeah, no problem. Actually, I might be able to type that in for you. So let me type in this effect for everybody. All right. It's how to prevent. So let me go in and do that for your team 4. Okay. So we'll get you guys in here. And I'll do that for the rest as well. Looks like I'm out. There we go. All right, should be ready now. All right, you guys should be able to go to your teams now. And if it's just one, talk to me if your team's not there or something. Let's talk about what that effect going to have on you. All right, I think we've got most everybody back. Just a few more people. Let's go ahead and start with team 1. Let's get you guys started. Who's going to be talking for team 1?
I can talk. This should up.
Oh, good. Okay. Shadab, we'll see. So what were you thinking in terms of your categories?
So you're looking at methods, machinery, materials, and people.
You could have said manpower just to keep the M's going. I'm just saying.
I think we were using I think I got it messed up, but yeah, manpower was probably the best one to go with. But yeah, for consistency's sake, I think we had a little bit backwards. I think we were looking at the issues that can cause the lost tapes instead of how to prevent the lost tapes. So
no, you're actually not wrong. That's actually not a bad. Yeah, maybe I worded that bad. Yes, we probably should have titled it, "How did the lace tapes get lost?" And out of your analysis, you should have figured out, well, how can we prevent that? So actually, you're not wrong in attacking it that way. So with that in mind, what one were you able to go fairly deep into?
1 second. I would say the method. We were saying that since they had to be rebroadcasted and the amount of tapes that they were using and erasing and reusing caused the loss of tapes.
Yeah, that's true. Yeah. And what I was hoping is while you guys were talking about it, did you think of anything you could do to prevent the lost tapes once you analyze it?
I guess documenting the storage.
Yeah.
What it sounded like it was just a big storage facility and they had to track it down. So if they had a procedure of storing them, it probably would not get lost.
No, totally agree. No, I could see you attacked it from various angles, so that's good. But you're right. I probably should have had that to be why were they lost, and maybe that would have been a better thing to do it. Did the rest of you have the same issue, or did you guys attack it using? Let's see what Team 2 came up with. Team 2, do you guys have a spokesperson?
Yeah, so we kind of had the same issue. That's why we were kind of struggling a little bit.
Oh, you only came up with 2.
Yeah.
Okay.
So yeah, the data format and people.
Okay. So compatibility issues, definitely.
Yep.
And then the noise in different format. But with this in mind, what were you thinking from a people standpoint? Could you have prevented the lost tapes through your analysis?
Um.
The labeling.
Yeah, with the label. So.
Yeah.
Yeah.
Yeah, no, I can see that big, and there was a big issue with the data format, the equipment being different and having to convert the originals. That was that's probably more machinery, not people, but I can see where maybe method wise you could work that. Yeah, no, I probably screwed up by so sorry guys.
No problem.
Yeah. All right. Let's see if Team 3, maybe we were able to work this better. Who's speaking for Team 3? Anybody? Oh, much better. Okay. Jordan, is that you?
It's
Okay.
consistent with everybody else's idea, but we went with reproduction, poor documentation, lack of technology maturity, and lack of interest. So I guess where we were coming from lack of interest was the fact that the mission was completed and maybe they were working on other projects, had other assignments and stuff. So maybe they just didn't pay enough attention.
Yeah, no, I could see that.
It's like human error, technology maturity. So that's kind of similar to what I think former group was talking about in terms of like technology resources, maybe not updated. And then poor documentation, so the labeling issue, maybe inconsistent here, and reproduction. So they got to back up the files.
Yeah, no, that's a good point. And it's interesting because your lack of interest kind of bleeds into these others. You notice the change in project management because people move into new projects, right? So it's even the lack of interest is like, hey, I'm done, I'm out of here. Thus, neglecting the whole, what do we do with these tapes? Yeah, that's actually a real good one, lack of interest. Now, that may be more of a people thing. Like if you put that as a people and put that as one of the causes or whys, that may have worked out well here. So, but no, you guys did a good job. And look, they changed it up just to make it right. Good job, guys. Good job. Very good job. Thank you, Jordan. All right, Team 4. What do you guys have for me?
Yep.
All right, so that's Marcus.
Yep.
All right. Oh, you kept the M's. Good job.
Yep. Go along with Marcus.
Yeah. Yeah. Right.
But yeah. So we just tried to boil it down to the 4 M's. Oh, my computer just froze. Bear with me.
Oh, brutal. It's all right. We're just looking at your thing.
Yeah, but we basically took the same approach as everyone else did. So for methods, they couldn't find the tapes when they needed to, and then the tapes
Right.
guarded. And I think both of those kind of came down to there was no standard retention process or purge.
Right. No, that's absolutely the good answer.
Yeah. The machines, the data couldn't be transmitted.
Yep.
What time, and then all the issues they had with the magnetic tapes. So the no standard data type to begin with, and then storage on the tapes wasn't optimal for the task, and that kind of boils down to the machines and kind of the material as well. And then kind of like Team 3 said, for manpower, no one knew where the tapes were being held. No one really cared, but that's either way, it's a poor knowledge management process or pass downs or whatever when people go from job to job. And that even goes along with the tapes being discarded without someone objecting or caring that they were the actual moon landing tapes.
Yeah, good point. Yeah.
I mean, material just once again was, the magnetic tapes took up too much space and they didn't store enough stuff, so they had to be overwritten, and they just weren't the optimal solution for bulk storage. And then one thing we also talked about was the magnetic tapes, as they progressed through time, it doesn't seem like they upgraded. So you would think
right,
they had the stuff from the moon landing stored on would probably advance as technology advanced, but it looked like they kept the same processes in place, and that kind of they didn't upgrade the material in which they were storing or doing this bulk storage stuff. So that was another thing that could have contributed to it.
Yeah, that's a real. It's good. I think you guys are. I hope you guys kind of can sense how this method can lead you to some answers as to perhaps not only why the thing happened, but maybe what we can do to try to prevent it from happening again. So, good job, guys. You all did a good job. I apologize for not quite leading in the right thing, but I think a lot of you were able to get around it. So I really appreciate that. That's good. All right, let's go ahead and finish this up by getting, and I'll try to finish up by 6:30. I can hang with anybody if they want to talk. I'm going to probably get together with Team 4, talk about the CDR. They had some questions. If you have some questions too, let's hang out. Maybe go to your team and open up something for you guys to talk, and I can join you if you want me to. Just put that into the chat so I'll know that you want me to talk with you. So anyway, let's finish this up. Total quality management, and basically, I'm usually a big deal when it comes to talking about, and okay, I'm recording. I make a big deal out of quality because system engineering, the whole idea of quality is to satisfy the customer. And when you think about satisfying the customer, it's actually giving them what they want. Now, if they gave you their wants and their needs through the requirement process, theoretically, what we give them is what they wanted. So quality to a system engineer should be like the middle name, system quality engineering or something. But it should be something near to our hearts as we're working this. And of course, this is where quality can really help work within the implementation phase. And of course, it can only really work if the organization kind of has that commitment to bring quality into play and into focus as you're working this. And this is a great diagram that shows that you can actually worry about your cost and really get high quality. But if you go ahead and really get your quality up there, you might be able to get a real good sweet spot where the cost is low, but the quality is fairly high. So it's worth thinking about how you would actually get that point. Now, think about how would I get that price point or ask for even better pricing if I actually go in and improve the process. So I could actually lower, I'll get the quality even higher and even lower the price by doing that. So improving the process capability is the key to make that work. All right. So overall improvement in performance is better employee relations, higher productivity, better satisfaction from your customer point of view, and of course, increase market share and profitability. So it's well worth thinking about how can we bring quality into the system engineering process as well as into the program and the company that you're working for. Now, there are certain, you can look at quality in 4 stages. One is inspection. You're just looking at once they're done. Not quite a good idea. Quality control gives you a way to perhaps give you a statistical way to improve your processes. Quality assurance actually looks at the fact that trying to be very proactive. This will be a problem. How can I prevent it? But of course, if you drive it using the 5 driving philosophies of total quality management, you could actually work that a little better. And basically what you're trying to do is get quality from the customer's point of view and link that to the profitability, both from the market and the cost side. So looking at quality as a competitive weapon and actually linking it to your planning process and making sure you have your entire organization committed to the quality proposition that you're trying to do. So you need both that philosophy and the various tools. Now, there's soft people issues where management is leading the way, making sure defects are caught early and not and rewarding people who are helping you work that. Always keeping the customer in mind, trying to get them excited about what you're producing and making that one of the key aspects that you're trying to work. One thing you could look at is this thing that they developed for shipyards in Japan. And basically what they were looking at is the objective and what the customer needs. And you rank those needs and then you think, well, what design attributes could I have that will actually meet those needs? And then you actually look at your design attributes and go, well, what can I bring to bear in order to actually get them excited about the product that you're developing? Okay, I see, Rohit, we're going to talk about that after I finish here. So what's cool is if you do this right, like let's say you really want a door on your car to be easily shut, but you also want quiet in the car while you're driving. Well, it turns out the door and the way it shuts and how it seals the cabin will keep noise out, but that puts extra weight on the door. So how do you make sure the door will still shut with that extra weight? So those type of design attributes could actually go in your correlation matrix, and you can kind of work through it, making sure your customer perceptions are well done, all within a cost and feasibility aspect. So very neat way if you ever get a chance to look at that. By the way, this whole House of Quality, they wind up being fairly thick documents as you're going through it because you're trying to correlate and get relationships between the various important rankings of your requirements. The other thing is to look at actually looking at ways to get your quality improvement and reducing your cycle time. If you concentrate on prevention rather than inspection, you can really save a lot of money. Prevent the error from going into production is basically what you're doing. So put a lot of effort in that upfront and prevention aspects and processes in order to make sure it works. So you continue, you make this environment where you actually think and push for process improvements. Be willing to change completely what you're doing. Very difficult to do because a lot of companies really have honed their processes to a fine tooth edge where it's really competitive, but then somebody comes along and disrupts everything. Can you throw away that well-tuned process and come up with something else to make it work? And of course, in order to do that, it'd be good to have some kind of measurement that will help you understand what you're changing, some kind of evidence-based improvement. And that's where measurements come into play. And of course, benchmarks are usually very well thing to look at. You may even look at practices of competitors and try to implement them. Try not to get in trouble doing that, but do it in such a way that it's good for your organization and the way you would use it. And really get your employees involved. They're at the bottom line, front end, where the work gets done. So maybe pull together various team members from different teams, come up with this cross-functional team to actually look at ways to do improvements. And of course, there are different tools you can use, process maps, Poka-Yoke. Poka-Yoke's kind of like, I have a piece of equipment, it needs to actually fit into a slot, you know, and then add a slot in there so that that's the only way it can fit. Very easy, it helps with maintenance as well as production. So make it foolproof where things will slide into each other or something like that. Statistical tools are usually very helpful in getting that evidence that you need to figure out your changes that you need. Force field analysis or root cause, which we kind of did with our fishbone diagram, are again things that you can use to diagram the various forces that are up against what changes you need. The plan, do, check, act cycle is something that's usually used for any type of changing that needs to be made. And getting a bunch of participants together, maybe during one of these team meetings, do some brainstorming and get ideas out there. One of the keys to doing good brainstorming is to making sure that any idea is up. Try not to make fun of them. You never know if that one idea that may be funny, somebody else will take that and come up with a brilliant idea. So well worth doing it. Tree diagrams, trying to map out exactly what you're up against, as well as prioritization matrices. One thing I look at is try to explain what is good enough. Sometimes 99%, 99.9%, but there are issues even with something that well done. You really want to kind of get to a perfection type thing, and that's where Six Sigma, if you ever heard of that, it's a 9 with 99.99966. It's practically perfect. And of course, there's ways to, it's like 3.4 opportunities per million opportunities for a defect. It's really quite way. You can't get to there from here by just going your old ways. There are things you have to do to get your organization committed in order to allow you to achieve this. So bottom line, your system engineering, you should embrace quality management, know the design and work processes, and try to figure out ways to improve those processes in order to increase not only the efficiency of the work, but the quality as well. And it should be second nature to a system engineer. All right. Wow, that went a lot faster than I usually go. But I do want to talk to you about the aspects. Don't worry about printing here, but try to have each member present one aspects of the slides. What I'm hoping is that you'll go ahead and share. So I'll go ahead and you should be able to go in to the top up here where it says share your PowerPoint or your screen, whatever makes sense to you. If you can find one of your teammates to have a better computer system or something that's not as flaky with the CDR, with the Microsoft Teams, that would be great. And of course, don't forget your team file exchange. Now, I did want to talk, somebody mentioned this, and I have to apologize because I should have made a bigger deal. And this is what I get. I think we're all trying to get used to being online and not meeting each other as we go in. But if you recall, I have this Morton, not this one, sorry, that's the wrong one. I have a discussion board where I was asking you guys to go ahead and create threads. I forgot to mention that when we talked about the interfaces. Let's go ahead. Let's just kind of get you guys working through the PowerPoint and things like that. Usually I have this as a team project. Let's go down here to CDR. I usually look at interface and I see 15 points. I'll just go ahead and give you those 15 points to everybody. Just do your analysis, design, standards, and trade study, and making sure your core database is correct. You should be able to get 100. So I apologize for that. I'll send out an announcement for those who may be missing that you don't have to do the interface diagram. All right, now I notice Rohit wants to stay. Rohit, which team are you again? If you're there.
We're team 2.
Team 2, that'd be great. Okay, go ahead and start something, talk among yourselves. I'm going to talk to team 4 and just see what they need. If any of your other teams would like to talk with me, I'll be available here until 7 o'clock. Meanwhile, I suggest you guys talk among yourselves in terms of how well and how far along you are. Remember this expectation for the actual, what I'm looking for is an important aspect of getting a good grade. All right, so all right, let's go ahead, unless there are any questions. Give you guys a few minutes if you have anything. All right, sounds good. Let's go ahead and stop this one. If you want to start some meetings in your team things, I'll try to join you there and we can talk. All right, guys, this is it for today. We're going to stop this and end the meeting, and we'll check you around. Next week, we'll be starting the CDRs. Team 1 should be ready to rock and roll at 4:30. Okay? So if you have any questions, let me know. All right. Okay, I'm going to end the meeting. I'll meet you in your team meeting rooms.